Thank you, thank you, thank you. Yeah. Thank you very much. I think every day I'm forgetting you people are remembering me. Thank you very much. Okay. So yesterday, I think I will give a refresh on microcontroller and a PIC microcontroller. What are all the difference? So microcontroller, Intel manufacturer. PIC microcontroller, microchip is the manufacturer. And microcontroller, it's a 8-bit microcontroller only, 8051. This is also 8-bit microcontroller. Okay, memory we are having RAM and ROM memory only in 8051. But in PIC, we have RAM, ROM, EEPROM, stack memory is also there. Okay, so we can capable to burn the old program, and we can able to uh, upload the new program in our memory. That is the main advantage. Okay, and capture compare PW module is not available in 8051, but capture compare PW module is available. So using that, we can generate the various PWM pulses with the different duty cycle ratio. I think yesterday I have explained you how the capture compare PW model is working. Then here 8051 serial communication is only UART, but here we have a USART. Along with that, we have a SPI model, serial peripheral interface model. Then I2C protocol is also available. Okay, along with that, we have a parallel slave communication is also possible in 8051. Sorry, in PIC microcontroller. 8051, we don't have a watchdog timer. But PIC microcontroller, we have a watchdog timer. What the watchdog timer now? In real-time application, even the software fails, the watchdog timer will keep on it will keep on count the timings. So even the failure of program in your software, the watchdog timer will be used. Okay, it will keep on count the clock pulses. So that is the so we have a brownout timer is also there. What is the purpose of brownout timer na? I can work my voltage less than 2 to 4 volt. That is possible in brownout. So we can able to work in the low range of voltage using this kind of oscillators. Okay, so that is the main advantage of that. Okay, then other advantages, any skipped, I have skipped. Uh, Anything I have skipped. A to D converter, D to A converter is available in PIC microcontroller with 10-bit resolutions. Okay, and here only we have 4 ports: port 0, port 1, port 2, port 3. Here we are having 5 ports: port A, port B, port C, port D, and port E. And one more thing, the capacity, memory capacity is on-chip memory is here 2 KB ROM and 256 bytes RAM in 8051. But when I move on to PIC microcontroller with 8 KB ROM will be there, and 356 bytes RAM will be there, and 256 bytes EEPROM will be there. So these are the thing. While I compared, I think I have compared, listed out all the points between 8051 and PIC microcontroller, and both are using a RISC architecture. 8051 is using Cisco architecture, and PIC microcontroller is using RISC architecture. So 8051, 255 instructions are there, and here 35 instructions. So this, and one machine cycle, it's by 1 by 12th of the clock frequency, 1 by 12, and but here in here 1 by 4th. Okay, so today you have to attend the kagot. So I have listed out some point, so that will be useful while you are attending your quiz. Okay, now we will see the addressing modes. Instruction sets are there. Today we try to cover because only 35 instructions are there. I think some assembly language programming, whatever we used, some same thing only we will use. But the name here they are because that processor, they are Intel, and this is microchip technology. So the term that will differ, but the purpose will be same purpose only. Okay. So today we are going to see about the 5 registers, five CPU registers. It's are the very important registers. Working register, the first one. Working register, they will simply mention W. It's nothing but a accumulator only, because they are saying working register or accumulator, both are same only. Then status register, I told you yesterday itself, Rahul Kar, Uh, what is the other name of status register we used in 8051 ma? Status register is similar to what? Accumulator is similar to working register. Ragul Kaur is present, or he went yesterday. I have told him one thing. Yeah, Ragul Kaur.
Ma'am,
Yeah, tell me,
ma'am,
ma. Status register
uh,
in 8051. What is the name of that status register? In PIC
um,
microcontroller, we are saying status register. In 8051, what is the name of that? Which register is used for bank select?
flag register, ma'am.
Yeah, flag register. Very good. Flag register or PSW register. Okay, put your mic in mute. So here we are saying status register. There the name is flag register or program status word register. Okay. Then file select register. It's mainly used as a address pointer in indirect memory addressing. Okay, INDF address, program counter. So these are the five register indirect address only. They have mentioned INDF. Okay, these are the five CPU registers, very important. Okay, so I told you working register is nothing but accumulator. So after all arithmetic and logical operation, my result will be stored in working register. Working register is mentioned as a W. Are you clear? So we are don't get confused, because the manufacturer is different, that's why the name is different, but the purpose will be same only. Okay, so status register, what he said now, status register is a flag register. So whatever the flag we have seen there, zero flag, auxiliary carry flag, parity flag, okay, and carry flag will be there. Similarly, here also we have a three flags are there. Carry flag, C stands for carry flag, Z stands for zero flag, DC digit carry flag. What is digit carry flag now? There we have seen auxiliary carry flag now. During BCD addition, after my fourth nibble, if any carry is generated, it will move to the fifth bit. The same purpose is here. So don't think that digit carry is nothing but auxiliary carry bit. Are you clear? So auxiliary carry means here we say is a digit carry. So you just see bit 0, bit 1, bit 2. I think you have seen carry or borrow. We used to say. So whenever my this 8-bit microcontroller, we all know PIC microcontroller is a 8-bit microcontroller. So if my accumulator, definitely my accumulator length or working register length is also 8-bit. So if it goes beyond 8-bit, at that time the carry flag will set. If there is no if it not exits 8-bit now, the carry flag will not reset. So mainly it is used during addition, subtraction, and during rotate instruction also we will use the carry flag. Okay, the next one is digit carry. I told you it's nothing but a auxiliary carry. Don't get confused. Digit carry is nothing but a auxiliary carry. So obviously, if I am doing my BCD addition, my lower nibble, that is 4 bits, if my carry is generated from third bit to fourth bit, so automatically what happened, the digit carry flag will set. Then 0 bit, we all know the working register or accumulator value is 0, means 0 flag will set, otherwise 0 flag will reset. So these are the three flag. Oh my god, ma'am, once again. Okay, ma. One thing. Okay. So these are the 3 bits for only flag registers. Okay. Now you come to this RP1, RP0. It's nothing but a bank selector. We already seen here we have a 4 banks are there. So 00 means bank 0, bank 1, bank 2, bank 3, that we have used. So they have you see each bank register having 128 bytes. So 00 to 7F. Okay, 80, there we have seen till in 8051 only we will use to say 256 bytes will be there. So 128 bytes for general purpose register and for the addressing. Okay, and the remaining 128 bytes for the special function register. But it is not like that here. So here we have seen four banks are there. How the four banks are selected now? By using these two bits. Okay, now you come to the seventh bit, bit 7. So in bit 7 we have an option of that. What is the option now? This is mainly used in indirect addressing mode. So if this is 0 means it will select bank 0 to 1. Bank 0 to 1 means what? 00 to ff. You all know 00 to 7f now. So you have to know that this is 128 bytes. Are you clear? This is 128 bytes. So when you see that, if my IRP is 0 is nana, so totally it will select 256 bytes. So that they have specified that. So here 0 means the 0 means it will select two banks, bank 0 and bank 1. 1 means it will select bank 2 and bank 3. Are you clear? So these three bits they are allocated. These two bits for direct addressing modes. I can select the four banks, and in this is used in indirect addressing mode. If 0 means it will select bank 0 and bank 1. If it is 1 na, bank 2 and bank 3. Why it is 0 and 1 na? We are saying 002 FFF. So obviously it will take that. The next bank we all know 1002 FF, 1 FFF. So this one denotes that bank 2 and bank 3. Okay, then that two bits, these two bits, this two bits is for mainly for timeout bit and power down bit. And we have so many oscillators are there. Clock oscillators are there, power on oscillators are there, watchdog timers are there, brownout oscillators are there. So here um, the value is 0 or 1. You all understand? We can't able to, you have seen these two bits are readable bit. That means depending upon the timer operation only, the particular we can't able to write anything here. So it's an internal operation. Can you understand or not? The remaining bit we can read write option is available, but this two particular bit we have only read operation. So if it is one CLR, what is CLR ma? CLR ma? தெரியல மேம், அப்படி ஒரு இன்ஸ்ட்ரக்ஷன்ஸ் வருது. 10 மினிட்ஸ்ல மீட் அங்க ஒன்று. ஓ, அப்ப நம்ம ஹச்ஓடி சட்டு தான் சொல்லணுமா? நீங்க மேம் சங்கீதா மேம் வேணா பார்த்து சொல்லுங்க. யாமா. So CLR means what ma? What is CLR?
Clear, ma'am.
Very good. Clear R. But WTT, what is WTT? Anyone can tell? CLR clear, you all know. WTT, watchdog timer. Are you clear? So clear watchdog timer. We all know sleep instruction. See, sleep instruction means in your laptop you will put sleep. Then when you switch on, at what step you have turned off or put it in sleep mode. In the same step, no applications will be closed, but the oscillator will be turned off. The same thing here. So timeout is 1 and 0. So 1 is means after power of watch dog instruction or sleep instruction, both it will work. 0 means watchdog time will occur. That means it will keep on counting. Okay, then power down. Okay. See students ma, if meeting got end, okay, you just once again you wait. I will restart because there is a problem in continuing that. So if any time it got shut down, don't think that the class gets over. It will over by 10:30 only. So once again you just go to your link. I will once again I will start the meeting. Okay, then again this 2 0, again 1 for clear the watchdog instruction and 0 for execution of the sleep instruction. So one is power down mode bit and another one is time down. So we can understand power means due to power this particular bit will be there, and due to time that particular bit will be enabled. So it is due to the occurrence of the timer, and it is due to the occurrence of the voltage level. Okay, so status register is one of the important registers in the PIC microcontroller. So because we in like 8051 we are not going to learn all the registers, because we have so many special function registers for each and every register. It's very difficult for us to remember. So we are going to study only the 5 register remaining, and all just we are going to name the only. We are not going to see the configuration of the registers. So the status register is very important on selecting the flags like carry, digit carry, zero flag, and mainly for selecting the banks in direct addressing mode and indirect addressing mode. Okay, the next one is file select register, FSR. So mainly this FSR will be used in indirect addressing mode only. We will use this FSR, file select register. So the file select register, I gave you the main thing. So file select registers will be in the bank register only. So what happen now, whenever the file selector register will block the location, or it will point out the thing, that particular file select register will move the content to INDF register. Okay, indirect file register, that will move. So it will automatic, it will move, will be there. But you have to remember, file select register is nothing but when I'm taking any bank register, the particular register they will allocate for FSR. FSR means file select register. It is an you mainly used for pointing out the address in indirect addressing mode. So whenever FSR will be loaded, the same value will be moved to INDF register. Okay, that is indirect file register. That is though. So this two register is not a physical. This address will be there. This we can't able to. It mainly used to pointing out the address. Pointing out the address only. We will use the indirect file register. Okay. The next one is program counter. What is the memory capacity of PIC microcontroller, ma? What is the programming memory capacity? Programming, Sublakshmi. Sublakshmi, are you present today, Sublakshmi?
Present, ma'am.
Yeah, tell me the programming memory capacity. We have three memories are there.
8
Pro-
KB, ma'am.
yeah, what ma?
8 KB, ma'am.
Very good, very good. She said 8 kb. Very good. The 8 kb. 8 kb means we all know the length is 00002 1 f. So what is the maximum? One means what ma? One they will spend 1111 for 1f, 11111, 11111. So when you take this 4, 8, 12 and 113. So how many bits are there, ma? 13 bits are there, because it's a 13-bit counter. Or you understand, program counter will always hold the address of the next instruction. That will be similar. So program counter, the maximum length is 13-bit. 13-bit means we specified from 0 to 12-bit. Are you clear? So here what they were saying now, the 8-bit they will allocate the program, that is lower bit will be there, then upper PCLATH, that is nothing but program counter latch. Latch means it will do the read and write operation, because here we have a EEPROM memory that have a capability to do both read operation as well as write operation. But what is the length of program counter? 13-bit. Why ma? My memory capacity is 8 kb. 8 kb means what? Maximum length is what? 1 fff. 1 fff means if I convert into binary, the total length will be 13-bit. So that's why it is a 13-bit counter. So you have to remember a small recap on CPU register. Working register is a accumulator. Okay, and status register is nothing but a flag register. Okay, FSR means file select register. Okay, and INDF, that is also nothing but a indirect file register. Mainly it is used for indirect addressing mode. While writing program only, we will use this register. And program counter is a 13-bit program counter. So these are all the